This episode of the Unbuilt It podcast is brought to you by Huber Engineered Woods, makers of Advantech subfloor assembly products. Engineered with long-lasting strength, moisture resistance, and nail-holding power, Advantech subfloor is the brand builders trust for quality subfloor. Combine the strength and moisture resistance of Advantech panels with the bonding power of Advantech subfloor adhesive for a solid, even subfloor assembly, perfect for a variety of floor applications. Follow along with builders and their Bringing Their A-Game campaign on the Advantech Subflooring YouTube channel, at Huberwood on Instagram, and their new website. Visit advantechagame.com. Thank you, Huber Engineered Woods. Welcome to the Unbuilt It podcast. I'm Jake Bruton, and today I'm joined by my co-host, Peter Yost, and our guest, Allen Sealock. And we are recording live from a secure location that is COVID-19 free.
Nice. all the way around, right?
Yes,
all
exactly.
Of us are free.
So I wanted to start by saying, Allen, welcome. And rather than introduce you, other than I think that all of us have known you for a few years and have worked together, I'm going to let you introduce yourself, and then we'll quiz you on your own bio stuff and go back a little deeper than your current position as well.
Sounds good. Good to be here. Allen Sealock. I work with Huber Engineered Woods. We manufacture zip system, sheathing, and tape products, and Advantech subflooring. So, thanks for having me on.
And full disclosure, we both have worked with Allen on stuff before in the past, and like Allen, even though they're a sponsor, we would have had him on even if they weren't a sponsor.
That's right.
So what is your position with Huber, Allen?
I'm the product director for the zip system line of products.
Okay. It's all I can do just because I like you and we have a good relationship when you say that, for me not to just go, ooh, like.
Yeah, I don't, job titles. I
knew that's not what you would say.
That's what's on my business card.
I knew that would be how you feel about it too. That's fantastic. And so how long have you been in that position with Huber?
I've been in my current role with Huber about 5 years. It's out of our headquarters office in Charlotte, North Carolina. But I've been with Huber for a total of about 13 years. Prior to my current role, I worked in our R&D, new product development group down in Georgia, where I was the technical director on zip system, and then some other kind of product development roles for about 8 years prior to moving into my current role.
So how the hell did you end up at Huber?
Well, prior to Huber, I worked for a brief stint with another wood products manufacturer, Louisiana Pacific. In that role, I was working in a OSB mill, though, so I was more in the manufacturing side. I went to school for forestry at University of Georgia, so I got a bachelor's and master's in forestry. So my whole career has pretty much been in wood in one form or another.
So did you think when you were a forester that you'd end up in wood products? Because I took some cars in forestry. I wanted to be out with the big rigs hauling down trees and stuff.
Yeah, no, I didn't anticipate ending up where I did. I mean, I'm glad that it's the way it's worked out, and I've had the good fortune of mentoring other forestry students and encourage them to kind of keep an open mind about where the wood products industry could lead them, because there's plenty of opportunities that go beyond just traditional forestry, which, to your point, Peter, that's probably what most people think they're going to be doing when they graduate. But the industry's huge, a lot of opportunities.
It's very broad too. That's probably a good take on it, is that you could go just about anywhere. We build all kinds of things out of wood.
Definitely.
So, Alan, we push Steve a little bit on his military background. Is it true that you have a military background as well?
Yeah, that's true. I was in the Air Force for 4 years after I finished up at Georgia. So I was an aircraft maintenance officer.
I wonder if that's
some
why
time overseas.
Steve volunteered to step out today, because he didn't want to hear anybody talk about being in the Air Force.
That's jealousy right there.
Yeah. You were
good.
always above him, right?
Yeah, that's right.
Please tell me that's not a standard joke in the military. Is that a standard joke?
No,
Okay.
no,
All right,
no.
just making sure. So with Zip, well, let's just talk about the Zip line for a minute. Peter has, the past few episodes, given a great introduction for your guys' ad read for the show. And Peter talks about the systems approach. And I was wondering if we just start there. Let's talk about how Zip developed and where it is today.
Sure. Yeah, we launched Zip back around 2006, 2007. It's right around the time that I started working for Huber. And, we had a major focus at the time. We were coming off great success with Advantech subfloor. Really transitioning our company from a commodity producer of OSB, really focusing heavily on trying to develop value-added products, and built out a R&D team. And the concept of Zip was grown out of that group. And we had some people there who had been a framer. One guy in particular had been a framer in his past, and came up with the idea, primarily interested in roofing at the time, trying to develop a product that could replace roof felt. And so they really spent a lot of time trying to identify materials that you could integrate into a structural panel that would have that moisture resistance needed for an underlayment or a water resistant barrier on the wall, and then find ways to seal the seams to get the necessary continuity. And so really, in the beginning, it was 4x8 panel with seam tape, and we've evaluated all kinds of opportunities to seam seal, whether it be fluids or various tapes or different types of profiled edges, shiplapped edges on the panel and so forth, but landed on our seam sealing tape. And we've really tried to grow the product line to continue to build on that platform of integration of multiple functionality, capitalizing on things going on with air tightness, for instance, and continuous insulation. With our R sheathing, the Zip System R sheathing panel, we've added that exterior insulation functionality. Different tapes, stretch tape, liquid flash. So we're continuing to really try to build out the portfolio of products for sure.
Hey, Alan, I'll bet you that when you thought about adding to the functionality of OSB and you got that polymer coating, was that mainly to make it into a rigid WRB, or did you also think of it as an air barrier at that point?
Yeah, good question. Somebody may have thought of it as an air barrier, but if you go back in time,
interesting.
Knowing that we were launching the product and call it 2006, we'll say it was 2006, and it was in development for, we'll say, 4 or 5 years prior to really being commercialized. Knowledge of air barriers was pretty limited, especially in a company like ours at that time, which were an OSB manufacturer, right? So, and yes, we had a really good, durable, highly moisture resistant product in the form of Advantech, but ultimately we were an OSB company. And a lot of what happened is luck. We had the right product at the right time when we introduced Zip, and things were changing in the world and building codes and building practices. People were getting smarter about it. And so we began to realize early on that there were some trends happening with air tightness. And at that time, we had just hired a true building scientist, and he was educating us. He knew what was going on. We didn't really know. And the fact that we had a rigid product with the seam sealing, we learned quickly that it could provide significant benefit in regards to air tightness. But I wouldn't say that in the beginning that's what we were thinking.
I'm okay with that.
Yeah,
I'm okay with stumbling into something that works nicely. I mean, that's the way I do half of the stuff that I do.
Yeah.
Yeah. And so, Alan, you must have worked really, really hard on that tape, because that's how you and I met. Was if you're going to have a top leading edge that's not weather lapped, it better stick really, really well. So searching for that tape must have also been a big deal.
Sure. Yeah. We continue to work on the tape, and it definitely is not a scenario where we just went out and found a commercially available tape and said, let's use this to tape our panels together. That's not really the case. We worked with a partner to develop the zip system tape to meet the requirements, the demanding requirements of a water resistant barrier and the weathering that it would need to be exposed for as long as it can be. And so a lot of effort went into it, a lot of competitive testing of other products and trying to ensure that we had the best tape available, and that's ongoing.
Mm-hmm. And so I get asked this question a lot, like, well, what's the vapor permeability of the green or the brown coating compared to the OSB panel? That's like one of the first questions that pops out of people's builders who are familiar with vapor permeability.
Right. Yeah. Vapor permeance. It's a funny
good
topic.
Shrug there from Alan before he started to answer this question. For those of you that can't see what's going on.
It's funny because I find that, there's a lot of effort spent talking about vapor permeance, and I'm sure you've been in a similar situation. I've sat in so many seminars and presentations, and it'll go something like this. They'll introduce the concept of vapor permeance, and then they'll go on to say how weak of a force vapor diffusion is compared to things like air leakage. And then they'll go, well, let's spend the next hour talking about this super weak force versus the ones that are much more critical, like bulk water and air leakage. But to get to your actual question, though, the vapor permeance of the membrane on zip is somewhere in the 12 to 16 perms in the wet cup method of testing. But it is bonded to an OSB substrate, and any multi-layered material will ultimately be controlled by the layer that has the lowest vapor permeance. So if you were to test zip panel, the weakest link, yeah. So the zip panel as a whole is going to come in somewhere probably around 2 perms because the OSB is lower permeance. And nobody is ever going to be able to get their hands on just the membrane because we don't sell it that way. It's fused to the panel. So
yeah, so it's the coating's contribution to how much vapor moves through is really almost incidental compared to the vapor permeance of the OSB.
Correct. Yeah, I mean the key thing is it's more vapor open than the substrate. So if it was
by a long shot, yeah.
Right, exactly.
So let's real quick sidebar just for a building science conversation, not about zip panel. Would either one of you like to take on the task of explaining the difference between the wet cup test and the dry cup test and why it would matter? And do we want to put that to Alan so he has to do it?
I'll take a stab at that.
Yeah. I'm going to go get some alcohol. I'll be right back.
It's one of those things that every manufacturer you talk to
conversation
says, oh, well, it's just like Alan did. Well, in the dry cup or in the wet cups, and it's like that's something that gets kicked around. And you know what? It never gets explained. I've looked it up, so I feel like I have a grasp, but it never gets explained. It never gets talked about in depth.
Yeah, I guess we can geek out on this for just a second, but I'll try to keep it brief. Basically, the wet cup method is tested at humidity conditions that I would consider to be more representative of what a water-resistant barrier would be exposed to in the real world. So you have your sample that you're evaluating sealed to a cup, and in the cup is water, and so that's 100% humidity. That cup is placed in a chamber that's at 50% humidity, and so
causing a pressure difference to draw.
Exactly. So your moisture is moving from the cup through the panel into the chamber. And it's basically the inverse with the dry cup. You have a desiccant in the cup placed in the 50% humidity chamber, and then you're driving moisture inward through the sample.
Like we said, Nerdville. I think it's interesting. I've never seen it in person, so I think it's something that I want to see at some point. So if I do wrangle my way into one of those tours of your R&D facility, I want to physically see it. And I don't want to do a clear solo cup with a piece of drywall caulked to the top of it and my vacuum hooked to the other side of it either. So
yeah, and the key thing is, I got to chime in here that there are some materials, the dry cup and the wet cup's the same because it doesn't change, and those tend to be non-porous materials. And then materials that are porous or fibrous, there's a huge difference between how much vapor moves through when they're dry compared to how much vapor moves through when they're wet. And so I remember in a session with Joe, and somebody said, "Hey Joe, is it a good thing that the vapor permeance does or doesn't change for different materials?" And Joe's answer was yes. The answer to every building science question is yes. Or fantastic. It depends. It's one or the other.
I'm going to put that in my back pocket. I'm going to keep that in mind from now on. Excuse me. So let's talk about the difference between, since you're in the zip department, let's talk about the difference between zip and regular OSB or commodity OSB to start out with.
Sure. Well, I mean, obviously the primary difference is the integrated WRB onto the panel. Which I'll take a moment just to describe that, because I find that, some people, when I'm talking to them about the product, they think that we've painted something onto a piece of OSB or we glued something on.
A lot of people use the term fluid applied process. And they say, well, it's just fluid applied at the factory. But that's not the case?
That's not really the case, no. So it is applied in the factory, but it is a sheet good membrane that is introduced into our process when we're making the OSB panel. So if you think about a 7/16 inch thick piece of OSB prior to getting pressed, it's going to be several inches thick of wood flakes and resin, glues and such. Well, in the case of zip, that membrane is riding on top of that mat of flakes, and then it all goes into the press at the same time and gets fused together, which is a lot different, results in a lot better durability than say if we took a 4x8 sheet of OSB and then ran it through a laminator and glued something to it. In the case of zip, that green membrane it's basically impossible to get off without damaging the panel and the wood with it. Whereas, take for instance like a radiant barrier product which has aluminum foil to it. There's a lot of those on the market. That would be an example of a product that has a overlay glued to it through like a roll coater. You could
almost like its own layer of plywood on the top, sort of thing, like that foil face is its own layer rather than glued together or pressed and formed so that they adhere to each other. I'm for those of you that are listening, I'm interlocking my fingers to try to describe that. I don't know if that comes across to my microphone or not.
And that's why I often, describe it as integrated. It's a truly integral component to the panel. That WRB is fused to the OSB. But beyond that, I mean, we do. I'll say that we juice our panel a little more than other OS commodity.
Like Jose
OSB.
Canseco?
Yeah, exactly. The secret sauce, the adhesives, the resins that are used in OSB, we use those at a little heavier rate, and specifically use an isocyanate MDI resin that would be uncommon to see that used in a 7/16 commodity sheathing. but it results in a much more moisture resistant wood product for sure. And that's what we use in Advantech. That's basically what makes Advantech so good.
And in the Advantech panel, are you just upping that resin count, or is there also a difference in how fibers are laid out or compression, things like that?
Yeah, all of the above. Yeah, I mean, but certainly the amount of that MDI resin is going to be one of the primary differentiators between that product and other products we make.
Can we talk about the term wafer board versus OSB for a second?
Yeah.
All right, and
sure,
can you
sure.
elaborate on what OSB means, since we all talk about it and we use that? And I mean, obviously, I know
Right.
what it means, but can you give us that oriented?
Yep. So OSB stands for Oriented Strand Board. So, we're buying full trees from loggers, landowners, pine trees, aspen trees, bringing them to our plant, and they go through something that would be similar to a large deli slicer, and they flake up the wood, credit card type size flakes. Goes through a drying process and screening, and then you begin to mix in those adhesives and so forth. And then when you lay down the flakes on this, what we call the forming line, where you're forming the mat that will ultimately go into the press, it's not just random. You're not just dumping wood flakes onto this conveyor belt. OSB's typically 3 to 5 layers, and each layer is laid down in such a way to try to maximize the structural properties of the panel. And so, the bottom layer and the top layer might be pointing, the flakes in the machine, what I'll call the machine direction, and then the core layer might be perpendicular to that, or more, in some cases, even more random than the effort you put into laying down the top and bottom layer.
Is it fair to call it like
more randomized?
Okay. Is it fair to call the OSB like a super complicated mesh of little pieces of plywood almost? Like you're looking at different layers that are oriented with particular goals? Or is that oversimplifying?
Yeah. I mean, it in a sense it is, because when plywood, veneers are oriented, differently as well. But
with plywood, you're peeling the big logs, right?
It is a different product that you're laying together
versus slicing. Yeah. But the term that you ask about, wafer board and such, that's really an old school term. OSB didn't really have a good reputation, and some people still don't like it, I guess. But back in the early days, it was manufactured differently than it is today, and it was really the introduction of Advantech and that use of the isocyanate resin that I refer to that elevated the whole industry. And other OSB manufacturers use it as well, and certainly have more robust subfloor products that use it. But back in the early days of OSB, that wasn't the case.
It's funny because I was just starting to be a carpenter when OSB was first introduced, and I think we forget that it was a product that was developed because, frankly, cutting down really big trees and peeling them into veneers, it was neat to see a product that could use smaller trees. And then the consistency of the material, I distinctly remember the first time, or actually the third time, that we were working on a roof and somebody put their hammer through a piece of plywood because there were matched voids. And then we ended up having to take up the roofing paper, the shingles, and start all over again on that 4x8 sheet. It's like, hey, we're switching to OSB because it's a more consistently reliable product. So in part, we were driven to that because the quality of the plywood just wasn't keeping up. So, it's not like we went out looking for just the new product. There were things happening with plywood that made it attractive to look at a different product. At least for us it was.
Sure.
That's interesting. Let's talk about, well, I'll add just as a sidebar, we went back and looked last week. I think that we've been using Zip since 2013. And I think the second job that I ever used Zip on, I went straight to Zip R. And then, because I learned about Zip, and then I was like, oh, wait, I can also get it with insulation on the outside and get continuous insulation. Like, oh, why would I buy the other stuff? And then I went back and looked a little while before that. I believe that our firm's been using Advantech for almost 20 years. So we have a long relationship with you guys that we're really happy and pleased with your products. And I know you weren't there 20 years ago. But it's very few and far between the products that I still use that we've been using for 20 years. And I realize that Advantech's probably not the same product that it was 20 years ago. There's been chemical changes, there's been formula changes or something. But I was trying to think of any products that we've been using for 20 years. And, Anderson's been making the same sort of 400 series window, maybe. Like it's the same thing. Like the same company's making it. So I think that's pretty cool. Peter, do you have another question? Sorry, I talked myself in a corner.
Because, I'm trying to think of the questions that come up to me about Zip in particular. And Alan, certainly one of them is, hey, when you overdrive a fastener in a piece of Zip, is that any different than overdriving a fastener in some other type of OSB? And if it does make a difference, does it make a difference for every piece of OSB? And how should we be controlling for whether fasteners are proud, flush, or countersunk?
Yeah, pretty common question for us. Our recommendation is to try to get the nails driven as flush as possible, which I recognize can be challenging, but there are some things that you can do to try to achieve that. The first concern with overdriven fasteners, which would be applicable to all sheathing products, is a reduction in the structural capacity of that panel, specifically shear resistance. And there's even some things in the building code about reduction of shear resistance associated with overdriven fasteners, but I think most often, when people are asking me about it, they're more so asking from the standpoint of how's it going to impact the moisture resistance, being that Zip system's functioning as that WRB. And I'd say that it's funny that when people ask me that, and then I often will ask them, well, what WRB are you using currently? And then they'll tell me something, some roll applied, to the house wrap, for instance. And I'll say, well, how are you attaching that to the building? And then,
I use staples.
Varies, but sometimes you'll even, staples. And I'm like, interesting. So you're asking me about fastener penetrations and Zip, and you're using staples to put on a house wrap. And it's like they just don't necessarily immediately see,
I'm stabbing 1,000 holes there per wall.
Yeah, exactly. I mean, just about really all WRBs are going to have some sort of fastener penetration through them. Now, ideally, that wouldn't be the case. We'd have this fully monolithic barrier of protection with no penetrations, but that's not necessarily feasible. So, we don't require the treatment of fasteners unless they're really overdriven, like, where it's pretty much halfway through the panel or more, or, you've blown a hole through the panel, right? I mean, if you can see daylight, you should probably cover that hole up.
And we should also clarify, Alan, when you say nearly all or all WRBs are going to have a mechanical fastener through them, even on a roll-on product, you're still going to nail siding or rain screen and siding through that. You're still penetrating that in some way. So don't hear that and then go, hey, well, if I use a roll-on product, then I won't have that, because you still do. Or if you're even doing brick, there's somebody out there right now going, well, if I use brick, the brick doesn't get nailed to the building. Yeah, but the brick ties and the lintels do. At some point, either you're building two walls and I can walk in between the two, or you're putting fasteners through it.
In our case, I mean, it's really, again, we don't require it unless it's significantly overdriven. but it comes down to what the builder or the end user is comfortable with. We have plenty of products, tapes, liquid flash that can be used to treat fasteners, and many people do so, especially the ones who are concerned about quality and take it very seriously. And so, we try to make sure we have products available that can be used to do that. But if, the bare minimum installation, it would not require the covering.
And Alan, I've seen the test that you've done. It's like a hurricane force with an airplane engine throwing the water at the panel. And it's not as if you're just waving your hands saying, the water doesn't get through. You've done quite a bit of testing under extreme conditions.
Certainly. Yeah, certainly. I mean, there's all kinds of, the test I think you're referring to is a test that they use a lot in Florida, but it's called TAS 100. And it's like they have a big, like a swamp buggy, motor with a fan that's blowing wind that over 100 miles per hour.
Right.
Leave it up to the rednecks in Florida to come up with that.
Yeah.
No, let's just blow it. Let's blow the water toward it.
Yeah. But yeah, we've done plenty of testing to evaluate fasteners, but at the end of the day, is covering a fastener better than not covering a fastener? I mean, probably so.
Okay. Do you guys?
But I was just going to say, there's certainly, you guys recommend some nail gun tips. There's a bunch of things you can do to try to minimize how much you get over penetration. Because with a nail gun, it's easy to get happy, man, and just let it rip.
The first thing you might do is just tell the framer to try to drive them flush. I mean, that's probably step number one.
Right.
If they
Simple
don't know what the
conversation.
goal is, they're not going to do it.
Yeah.
Exactly.
Clear communication. I'll tell you what we do on our job sites is, especially with Zip R, because there is that little bit of compression that's there with the polyiso on the back. We have a pressure regulator that connects directly to the gun, because I'm more likely to fiddle with the pressure while I'm up on the ladder rather than have to walk to the compressor, climb down a ladder and walk to the compressor. I'm more likely to adjust it, or the framer's more likely to adjust it. We also provide those to our framers so that they don't have a leg to stand on when they say, well, you're just going to slow me down because I got to make trips back and forth to the compressor. And then the other thing that we do when we're framing in-house is we have one person in charge of the nailing sheathing off for the day. We're never moving fast enough that it's going to matter that we're just letting one person nail off the sheathing. And even with a quality compressor, there's still fluctuations. You could also add a pressure tank in the line too. You could add, and we have once or twice. We don't do it normally because our pressure tank's a little big and unwieldy to have to pack around. But we have a 50-gallon pressure tank that we can feed from the compressor that's sitting next to the power pole to it, and then from that pressure tank to the guns, and that helps regulate things too. It helps a little.
Yeah, and quality control on this is not something that is unique to Zip. It's like, hey, if you want full structural value, get the fasteners flush.
Yep.
It's not that complicated.
So is this a good time to talk about the picture that I showed you guys before we started?
Oh, yeah.
Okay.
Yeah, we gotta show
I'll
that.
make sure that our Instagram account, the Unbuild It Podcast on Instagram, will post this when this episode airs so that you can see it. So what you gentlemen are looking at is we had some leftover zip panel, and we made a 5-sided box. And then the open side got shoved up against the back side, or the interior side of our Zip R. It's a 30-inch wide box, so it actually encompasses 2 vertical studs. And so we U-notched around both those studs, top and bottom of the box, so that we could shove it all the way tight to the back side of the polyiso. We then completely taped that box using a mix of zip tape and stretch tape to the polyiso. And then we were able to cut a circle out and attach our Retrotech 5000 blower fan to it. And then we put our manometer inside the box because it works on Wi-Fi with my phone. So we're able to take the pressure reading inside the box as if we were standing inside the house. And then we depressurized that section of the wall. And that section of the wall was chosen because one of those studs is a break in the panel, which is taped on the outside. And then the other stud has two fasteners. One that missed the stud completely and is just in the field and poking through the wall. And the other one that just barely touched the stud. And then the component that you can't see in the picture is we put a garden hose misting the outside of the wall with fairly heavy water. And we ran that fan for 45 minutes, depressurizing to 150 pascals. Now, the 150 pascals, especially according to Retrotech even, might be a slightly skewed reading because the volume of that box is so small, and it's not normally set up for that. Now, we could do this with a duct blaster, but we don't have a duct blaster, so we just use the blower door fan. And we ran that thing for 45 minutes with water pressure on the outside and 150 pascals of negative pressure pulling on that. And not only did we not see a leak, but the moisture content of the board that the nails were poking through didn't change either.
So I have a very serious concern here. I don't see a wing nut hat anywhere here. This is definitely, you know, this is unauthorized wing nut testing for sure.
Thank you. Oh, we also were smart enough to add a plexi panel to one side of that zip so that we could see inside. Although we realized after we got everything taped in, this is behind the scenes, we realized the first time after we got everything taped in that I had taped the fan in backwards, which wasn't going to do us any good. And I'd wasted all that zip tape around the outside and stretch tape, not the cheapest of the cheap. And then we realized that we put the plexiglass panel on the side where we couldn't actually see the nail heads anymore. So it was a really well thought out test. It was just poorly executed to start out with. But after we got it sorted, I was really excited to see what happened and see whether or not we could make it leak. Now, I realize, A, this is not an ASTM standard test, and B, in reality, 150 pascals of negative pressure on two nail heads and one seam in a 3-foot section is not a realistic test pressure. And then I was very impressed that one of my employees said, yeah, but we're going to have a rain screen and siding on the outside. What is the percentage of water that's going to get past that's even going to see that nail head? I was like, yeah, I agree completely, but we're still trying to see if we can make it leak, and we couldn't. So, hooray for you, Alan. Good work. We couldn't get it to leak.
I like it.
Now, how far off of an ASTM test is that test?
You know, it's not that far off, really. There's a couple of ASTM tests. E331 is one you'll often hear, where you are pressurizing and spraying the wall, and then there's a field version that I think it's 1105, if I remember correctly. And so they do these primarily on like multifamily projects, but they'll attach a spray rack to the exterior of the building and then pull a vacuum on the inside, very similar to what you're doing. And then somebody else, and the whole wall cavity will be sealed off with heavy duty plastic. And then some guy will stand there with a flashlight looking, for leaks to come through. So it's actually very similar to a field run ASTM test.
Way to go, Jake.
Does that mean that you're going to mail me one of those goofy, ridiculous hats, Peter?
You can get those from the Detroit Red Wings fan club.
Can you
That's
really?
That's the only place I've ever been. And the really interesting thing is that on the one wing nut side it says right wing, and on the other one it says left wing. So, for political purposes, you can wear it different ways. Yeah, okay. Turn it different ways.
I just assumed that you had dumped like a year's worth of savings into those hats, and then they never took off, and you had a basement full of them.
No, I think they're about $25 a piece. They're not cheap. And one of my wings fell off, so I had to stretch tape it back on.
And so, Alan, now that we're on Zip-R, the question that we get all the time is Zip-R going to be available for roofs?
Yeah, another common question we get. We recently changed our stance on Zip-R on the roof just earlier this year. Ever since we launched Zip-R, it was really only approved for wall usage, but we are going to start allowing it on the roof now. And it's a little different application, though. In the case, as you know, on the wall, you can install it directly to framing, and it still has structural contribution. You know, it either meets the bracing requirements or contributes to shear wall design. We're able to do that because there's a fairly clear process in which you evaluate a sheathing for those shear values and determine what kind of fastening schedule. It's another ASTM E72, I think it is, which is just a wall racking test. But in addition to the test protocol, ICC, the International Code Council, has acceptance criteria that is based on that wall racking test to determine if a proprietary sheathing, would meet the code required shear values. None of that really exists for the roof, and so that's why we've been hesitant to allow it on the roof. But as you guys probably know, there's been nail-based roof products available for many years. And so what we decided to do is kind of follow their lead and mimic the requirements for how those products are installed. And in that case, unlike our wall use, the Zip-R on the roof would need to be installed over a roof deck, so over a structural roof deck. And that's the way pretty much all nail-based products are.
Does that mean that Huber's pushing for me to put Zip down on the roof and then Zip-R on top of that so they can sell it to me twice?
Hey, sounds good to me. The other thing that's a little bit unique is these nail-based products on the roof require large screws to fasten them down. Unlike, again, on the wall where we're using, standard nails. These are like SIP screws, so the big quarter size heads on them. Due to the type of fastener required, you would need to use an additional underlayment on top of the product after it's installed. So you could probably have like a rough dried in Zip-R roof, but then prior to finish covering, you need to put a synthetic underlayment over it, just due to those large fasteners.
So in other words, the penetration in that panel is a little big for you guys to be comfortable with the standard seam tape, in other words.
Right. I mean,
that's
if you see one of these screws, I'm sure it's a completely different thing. I mean, they're really robust screws. And so to assume that you could put that through a panel and not introduce risk of moisture, we just want to be conservative and recommend the use of the additional underlayment.
Hey, Alan, I'm going through my list of questions that I typically get, so I got to ask you this one too, which is, there are two other wood product companies that have introduced, panel wall systems that are mighty similar to Zip, and I'm happy to talk about how I think they might be different. But is this a case of flattery? In other words, imitation is flattery, or how does Huber put
flattery times with a patent running out? Is that what you're saying?
No, I think you're right. I think that those products show that the category that Huber created, this integrated WRB sheathing category, is really starting to take hold and displace more traditional methods, more traditional WRBs. And so the fact that they're on the market now, I think it just proves that out.
Proof of concept. It proves that everybody else sees that it's working now too.
Sure.
Except for the Tyvek salesman out there, the house rep salesman. Sorry, I'm supposed to say that word here. What else? I
will say those. I'll just elaborate a little bit on those other products. I mean, and I won't get into how they might be made because I obviously haven't seen it with my own eyes. But, you know, I think one of the strengths we have at Huber is the breadth of the portfolio of products that we have. We've been in the zip game now for quite some time. And so, you know, but whether it be our sheathing like we've talked about, or stretch tape, or our liquid flash, or, you know, various dimensions of tape, and we've got a lot of product solutions depending on what the builder's trying to achieve. So I think that gives us a little bit of a leg up.
Yeah, I would say definitely.
I feel like we've been in the zip game for some time now. Sounds like a hip-hop lyric, and I like it. Peter's given us the wrap it up sign, but I want to talk real quick about pressure-sensitive adhesives, because how are you going to have a podcast with the two of you and not talk PSA and not talk about the idea of rolling it and the process by which it bonds? And so I would like to get that primer level, that Building Science 101 from Allen on pressure-sensitive adhesives.
But no pressure, Alan.
No.
Pressure.
Oh.
Yeah, thanks.
Wow. Wow.
You know, pressure sensitive adhesive, that pretty much all tapes are pressure sensitive adhesives, which means you need pressure in order to truly activate that adhesive and get it to flow into the substrate and achieve a good bond. I mean, even if you're not taping a building, I mean, we've all taped stuff. You know,
I use
cardboard box,
Scotch tape to wrap presents for my wife twice a year, on her birthday and on Christmas, and I have to rub that tape to get it to stick.
Yeah, so I mean, you know, or knock a wrinkle out of it, something. I mean, so it's really common sense in a way, you know. But we strongly recommend rolling the tape in order to achieve that good bond of adhesive to panel, for sure. Which again, all tapes should be rolled. It's not really unique to zip tape. It's all construction tapes should be rolled.
And you guys are wise enough to put it on the tape now. And I noticed today it was in Spanish as well.
Right. Yeah, we added it to the surface of the tape. It's been several years back in both English and Spanish. And I think I've mentioned to you before that the first Spanish translation, when I had somebody proof it for accuracy, they thought that it said, or what it actually said was, roll me the tape. You know, like take the roll and roll it over here to me. I was like, well, that's not really what we were going for.
Not
so
what we
we had
wanted.
to go back to the...
Now, I'm really disappointed you didn't consult with me on this, because if you consulted with me on this, on the tape, it would say, push it real good.
Wow, that's
That's how it would go.
two of those in one podcast. We're exceeding
Yes.
our Peter joke allotted limit on this podcast. You're bringing out a rare form here, Alan. So, since we're on pressure-sensitive adhesive and you didn't say the word that I was trying to get you to say, I'm going to ask you to say one of the, and you know this, one of the two words that you have taught me in our industry. The second one is durometer, and we can talk about that too if we need to. But I want you to tell our listeners about the other word that you have taught me, that you have learned me on.
Yeah, viscoelasticity. That's the fancy way of describing kind of the balance between solid and liquid characteristics of an adhesive.
And so people that have changed their own oil would recognize viscosity, the product's ability to flow, and then elasticity. If you've ever shopped for different varying sizes of underpants, so when we say viscoelasticity, we're really talking about the tape's ability to stretch and grab. So its ability to fill those pores and then attach. Right?
Exactly. Yep.
Okay.
Yep. Well,
Do you want to give us the completely unrelated, or not completely unrelated, mostly unrelated, durometer conversation?
Well, durometer is related because durometer is a way to measure the hardness of a rubber material, and you know we're always looking at optimizing our installation and evaluating our install tools and the roller that we have and the tape gun, and so we were looking at different hardnesses of that rubber roller to achieve the best roll down pressure. So it is, durometer would be related for sure.
Very good.
Score, Jay.
Do we have any closing remarks there, Peter?
No, I think I've just about zippity-doo-dot it for today.
The gray hair in your beard matches your humor, and I like it. That's part of what I like about you, Pete. Allen, thank you for joining us today.
Yeah, thanks, Alan.
Absolutely.
All of
Anytime.
our listeners, thank you for joining us today. I hope you enjoyed the Unbuild It podcast with myself, Jake Bruton, Peter Yost, and Allen Sealock. Don't forget to visit Huber Wood's new website. Thank you for reminding us that we needed to do that, everybody in the marketing department at Huber Wood. And then don't forget to follow Peter on Instagram. And if he knew what his Instagram was, he would be able to plug it. And don't forget to follow me, Jake.Bruton, on Instagram. Thanks for listening to the Unbuild It podcast. Till next time. Thanks.
See ya.